Okay, we'll start in a minute. Good afternoon, everybody.
Hello.
Hello, hi, sir.
Hi, how are you?
I'm fine, sir. We'll start now.
Uh-huh.
Okay.
Yeah.
Good afternoon, everyone, and a very warm welcome to all of you. On
Hi.
behalf of RUA Ecospaces LLP, I am delighted to welcome you to today's knowledge series webinar on rainwater harvesting. What, why, how? The water security and flood control techniques. I am architect Lekha Vishwas Kernar, green building analyst with RUA Ecospaces, and I will be your moderator for today's session. Before diving into our main session, I would like to briefly introduce you to RUA Ecospaces. RUA Ecospaces is a multidisciplinary consultancy specializing in sustainable architecture, green building design, environmental audits, green interiors, and capacity building. Founded and led by Dr. Roshni Udyavar Yehuda, who has over 2 decades of expertise, we help in creating resource efficient and humane spaces that combine global best practices with local context. We specialize in green building design and certification, providing end-to-end green building design and certification services, including LEED, IGBC, GRIHA, ASSOCHAM GEM, and EDGE. ECSBC certification. We are an empaneled organization for ECSBC certification, supporting energy efficient and code compliant building design. Green and energy audits. We conduct green and energy audits as an ISO 17020 2012 accredited Type A inspection body by NABCB and QCI for green audit. Green interiors. Our green interior solutions focus on human-centric, healthy, and environmentally responsible spaces. Training and capacity building. We offer workshops, technical trainings, and capacity building programs to promote sustainability awareness and expertise. MSME Z certification. We assist industries in achieving MSME Z certification to enhance quality, efficiency, and sustainable manufacturing practices. Carbon accounting and certification. We provide greenhouse gas emission inventory in accordance with ISO 14064 and related services such as GRI and TCFD index, SBTI, and BRSR sustainability reporting. Our vision is to create resource efficient, climate resilient, and net zero spaces that foster true ecological balance. We have had the privilege of bringing this vision to life across a diverse portfolio from hospitals like Dr. L.H. Hiranandani Hospital, which achieved LEED Platinum and ranked among 10 LEED hospitals in the world. Agrocell House headquarters, such as Agrocell House headquarters in Bhuj, Gujarat, high-rise residential projects such as Nahar Excalibur in Mumbai, and Arinda CHS, Navi Mumbai's first redevelopment green building. And our international projects include Heartland International School and North London Collegiate School in Dubai. Our sustainable community initiatives include the rainwater harvesting and Eco Hub initiatives at SVT College, Juhu, and sustainable landscape design of Mumbai Presidency Radio Club and MG Greens Township in Lonavala. We are incredibly excited to bring some of that sustainable design into our discussion today. Thank you all for joining us. So today's topic, water is one of the most precious resources, and yet today we the challenge of water scarcity and urban flooding. Rapid urbanization has reduced groundwater recharge while increasing stormwater runoff, making sustainable water management more important than ever. Rainwater harvesting is a practical solution that helps conserve water, recharge aquifers, reduce dependence on municipal supply, and minimize flooding. Today's webinar will explore the what, why, and how of a rainwater harvesting, covering its principles, technologies, and practical applications. We are honored to have an esteemed panel of experts who will share their knowledge and real-world experiences. With that, let us begin with today's knowledge series session. The first speaker for today is Dr. Roshni Udyavar Yehuda. Dr. Roshni Udyavar Yehuda is a practicing architect, academician, and sustainability expert with over 20 years of experience in energy efficient and environmental design of buildings. She is the CEO of RUA Ecospaces LLP and Roshni Udyavar and Associates, and is a certified master trainer and empaneled expert on the Energy Conservation Building Code, ECBC, by the Bureau of Energy Efficiency, Government of India. She has contributed extensively to green building research, policy, and sustainable design initiatives at both international and national levels. During her tenure as head of department with Rachna Sansad Institute of Environmental Architecture, she spearheaded a campaign, Harvest to Harness, along with the industry and NGO partners, which documented hundreds of rainwater harvesting projects across the country from 2005 to 2008. She was also a part of team that instituted and helped residential and commercial buildings in Mumbai to install rainwater harvesting projects. She was also involved in large watershed management projects such as Indapur and Thisep Township projects, Charlotte Lake and Dahisar River restoration, and Jesuri Lake restoration projects. With that context, let's begin today's session with someone who has dedicated her career to advancing sustainability and resource-efficient development. I would now like to invite Dr. Roshni Udyavar Yehuda to deliver the opening remarks and set the stage for today's discussions. Roshni ma'am, the floor is yours. Thank you.
Thank you, Lekha, for the introduction and for putting this webinar together. And a warm welcome to all the participants and the speakers who will the speakers will enlighten us through their expertise and their projects and their technologies about this subject of rainwater harvesting. We have made it the topic as why, what, and how, because we wanted to, explain some basic concepts about rainwater harvesting and maybe some examples, case studies. So it's going to be basics, but the second line, which talks about security, water security and flood control techniques, is equally important because today, we are, why we are talking about rainwater harvesting. India is a rain-fed country. We are on an average, we get about 1,000 of rainfall, and this is huge. There are countries which just get about 80 of rainfall, and yet they manage. But why we want to talk about water security is, even despite all that, we have water cuts, we have water shortages, we have all sorts of issues related to water. People are going through droughts, and people have to walk long to get water. So even though we have so much, we are blessed with so much of monsoon rain, we still go through all the problems of water, which we should not. And I believe one of the solutions for this is rainwater harvesting. And of course, the second reason that we kept this webinar now is because the rains are here. We can see the magic of the rains, how much water goes waste, everything. And then it is, easy to visualize and decide on why we should not, why we should all be doing rainwater harvesting. So as this slide shows, the bottom part, Pani Adva, Pani Jirva, that was the slogan that, sort of raised awareness on this important subject. And that's what rainwater harvesting is. It's actually capturing the rain and storing it for your use or recharging it into the groundwater. So simply, it is catching the rain where it falls and uses it. In Hindi or in Marathi, there is a saying that अगर पानी दौड़ रही है तो उसको चलाना चाहिए, और चल रही है तो उसको बिठाना चाहिए, और बैठ रही है तो सुलाना चाहिए. तो basic idea is that slow down the pace of water, because when water moves with speed and intensity, it carries all the stop soil with it. It carries along with it lots of things. And then it carries the water directly into the sea as well. As we have seen in Mumbai, so much of water, and all that water goes into our stormwater drains and sewage drains and everything, and then it's just wasted. And then there are times when we don't have water. So that's what rainwater harvesting is about. And that is why we are here to talk about this subject. And I want to show you a few examples, just two examples actually. One is Canary Cave. Those of you who are from Mumbai will realize that this 2000-year-old caves sitting in Borivali, the hills which are called Krishna. And on the top of there's so much water harvested just by following this simple technique of halting the flow of water. Simply, you can see how the monks who designed this or made these caves, they have made ways of cutting through the rock and making wedge for the water to flow into and store them into tanks. And we have seen it that even now, although it's on top of the hill, a lot of people climb up here to get water. I mean, this is how the ancient wisdom is. This is our vernacular wisdom. So these are the Canary Caves. You can see these are the cutouts and these are the tanks, beautiful. And even now they, have water and people can use them. So, each of the houses of the monks, outside each house, there is a tanki, and in which there is water. And even now you can go and visit and see these beautiful places. And this is another Moti Talav in Sawantwadi, which is, a talav which was built by one of the rulers there. And when there was a drought in this region, you can hardly imagine that in Konkan there was a drought, but there was a severe shortage, and he made a provision for a large lake. And this has helped recharge the water, all the water sources, the wells in the vicinity. And this kind of lakes we'll find all over, whether it is in Thane, Bhopal, and so many states and, cities all over India. And this is what rainwater harvesting is. In fact, all the water that we get in our taps to use is all nothing but rainwater harvesting. But a lot of it is going wasted. We are not concerned because, somewhere in some reservoir, what is getting collected, it is coming in our taps, so we are not bothered. However, what about our buildings? What about the water that goes out of the buildings and into the gutters? Can we not use that water and make use and, at least prevent the water shortages that people are facing? So that's what is we are talking about. So just a few things as an architect, since I'm going to talk about what are the design approach when you do rainwater harvesting. So the first four that you see are catchments, channels, first flush devices, filtration units. These are the four important things. And then the last two can be either or, like you can have storage tanks. If you have massive space and massive money to invest, you can have storage tanks, or you can recharge, or you can do both both are, everything is possible. But you must know about your catchments. You must prepare the channels for or the downtake pipes. You must have a first flush device and the filtration units if you want to use that rainwater. Maybe not for domestic purposes, although rainwater is the purest form of water and it can be, you can use it. But sometimes there is a pollution in the air, there is something on the roof, so you need to clean it up and then use it. So that's the only thing. Otherwise, rainwater is the best form of water. So those of you who have clean roofs and have a little farmhouse, you can 100% rely on rainwater harvesting and to provide water for yourself. You don't need to rely on any water supply. So when I talk about catchments, so these are all catchments. The lawn is a catchment, the roof of this building is a catchment, the road here is a catchment. You need to decide which catchment you want to take the water from, and then you can do that. Because sometimes if it is a road, there can be petrol, there can be diesel, whatever that mix up. So you have to be careful whenever you're charging also into the groundwater, that any kind of pollution should not get in. That should not be done, because they are going into the aquifers down below. And then channels like these pipes, and the horizontal and the vertical channels which carry the rainwater. So these are what I mean by channels. Then there is a plug. There is like a first flush device. For the first 7 days or so, the water can go out and the with the waste, and thereafter whatever water is there, it is clean. That's what we consider as a first flush device. Here's an example of a real first flush device that was done in a place called Kachegati in Aurangabad that visited many years ago. But I'll also talk about the simple rainwater harvesting technique that they have done. And then there is a filtration. I mean, simply speaking, this is a pressure filter that anybody can devise. We used to use these drums in which you can do it, but there are various ways. You can have tanks one after the other in which the water with charcoal, sand, gravel, and different sizes of gravel for the water to filter. That's just a simple understanding of how water can be filtered. These are called pressure filters, but you can have, and today there are lots of, I think some of the people here will be talking about that. And these are examples that of actual project that was in which we had the different types of filtration, and then the borewell was recharged so that where this was then connected to the flushing system, so that the flushing water was available for them through rainwater harvesting. And this is an example of a filter that was built into a downtake pipe. Just fit it into a downtake pipe at the first floor level, and then you can it has its own first flush device, its reverse valve for cleaning and all that. And then you can utilize the rainwater directly. So I'm sharing a very quickly a few examples. This was one of the projects in which we helped this particular society called Vinayak Darshan Housing Society in Dombivli. They had severe shortage of water, especially for the toilets, and they were using tankers. In this scenario, it makes sense to do rainwater harvesting, particularly. In this case, we had a borewell, and the borewell was recharged using the rooftop water, and then they connected that to their flushing system, and then it was utilized. And the residents were very happy, because it solved a problem for them. So in many, I remember housing societies, I think Dr. Kashyap is here, was worked on numerous projects, even in South Bombay, where this kind of projects have been done. So 40 residents, 200 tenants benefited due to the rainwater harvesting system. The second example I want to show you is a public project. It's not by us, but it is it's an exemplary project because it's done on public land. This is a Maharashtra Nature Park Society, MNP, if you have known, near Dharavi bus depot. It's about 37 acres of land, and there's a huge amount of greenery which was built on top of a dumping ground. Okay, but how much you require in the summers, especially water for many of the plants and nurseries and so on, and there was a lacking of water. And although it is right next to the Methi River, there was a shortage of water. So this rainwater harvesting tank was developed by the management of the park, and it harvested about 180 lakh liters of water. So all through, I mean, a park doesn't have a lot of, did have a circular office building from which, of course, the water was taken from the roof. But apart from that, every part of the park, the water was collected through pipes and it channeled into this lake. And this beautiful lake created also a lot of biodiversity. You could see fish, or a lot of birds, and different people started to come and just look at this particular lake, and it still is there. You can visit it. It's an excellent example of providing water for throughout the year using this kind of a system. So this is how the lake, this is the whole park, and you can see the lake occupied a small portion which was created much later. And these were the kind of water harvesting filters that were created throughout the park to help develop the system. The next project is a residential project. This did not require any, they did not have shortage of water, but they wanted to make a provision for water in case there is a shortage in the future. They had a bore well which was not used at all. So we decided to clean the bore well, recharge the water, and then, that bore well started working. We connected it to the flushing system. So whenever they wanted whenever they had a shortage, they could use it. So this is the kind of system. We put this pre-made or ready-made filters into the system, recharge the existing water, and it was working. And another example in South Bombay, PVM Gymkhana, where we use this rainwater, rooftop water for their regular. In December, they used to have a lot of events here in the outdoor areas. So for cleaning and such other purposes, we connected the water and stored it. I mean, you can do a lot of storage. So if you have space for storage, you can do the storage and use it. And this is a design, of course, I'm not going into detail, but in some places where there is difficulty of groundwater, groundwater table is high. I think Dr. Joshi will talk about it. But then what do we had to provide a lot of surface storage tanks in this case, and then allow all the storm water, to have small recharge pits and so on and so forth. So we did a little bit of that kind of work in order to see that how we can maximize the rainwater that is falling on this entire land. So these are some of the details of that, I think. So, a total of 1,42,000, sorry, a lot of water, 14,227 cubic meters was the annual rainwater harvesting potential. And what we did was 4 open wells, like open kind of systems, where we harvested 60,000 liters each. And then we had a lot of percolation pits along the stormwater and so on to make that system work. And this is an international example because everybody thinks, so this is in the state of Washington. This is the Phillips Merrill Lynch Center in Washington, D.C. I had visited this place. And so you can see these old wine barrels are nothing but rainwater harvesting tanks, because they get rainwater throughout the year, although the quantity is not very much, but it is there. So they harvest it, store it, and they use it for the toilets, which are right below them, and also for the cleaning of cars. Very important. People want their cars to be cleaned, but not with fresh water. So we say use this rainwater, which is collected. So this is how they had their parking lot where they had this tanks. And just one example, I want to show you one or two, maybe these are examples of that village called Kachigati in Aurangabad, very dry, and the people using local Shramdan, they created various sorts of watershed projects, like, small check dams. They made earthen dams, dams from whatever the material that was locally available to slow down the pace of water. And we could see the results in their wells. Their water table rose as they did these things, and the benefits were, availed by everybody in the farmers around, and all the villages around benefited from this. We could see that everywhere surrounding is dry, but this hillock was green because of the water harvesting that was done by the villagers. They used old drums, filled them with sand, and made them like a dam. So all sorts of things can be done. You don't need a lot of technology for doing this. So yeah, this is the beautiful hillock I mean, this is very old. I'd seen this almost 20, 25 years ago. And similar other projects of check dams in Kolhapur dams that you call them, even during the summer months, we see that even animals graze here. They like to drink water. So, and this kind of continuous contour trenches and check dams, they help keep a little bit of water, and then that is actually recharging the ground. So these are some of the examples that I wanted to share with you, and I'll stop now because there is a lot that is coming your way through the experts who are here. So thank you very much. If there are any questions, I'd be happy to answer. We can take them in the end. Thank you. Over to you, Lekha.
Thank you, Roshni ma'am, for your inspiring presentation and opening remarks. Before we continue, a quick reminder to all the participants, you may post your questions in the chat box at any time and we will address them during the question and answer session. It is now my pleasure to introduce you to our next speaker, Dr. Amar Joshi. He is a distinguished consulting geologist with over 40 years of experience in groundwater exploration, water conservation, managed aquifer recharge, and rainwater harvesting. Since 1984, he has been advising architects, industries, government agencies, and infrastructure projects on sustainable water resources and management. His expertise spans groundwater mapping, remote sensing, engineering geology, and the design of rainwater harvesting systems for both urban and rural development. Dr. Joshi has also contributed to several international water conservation initiatives and serves as a visiting faculty and advisor to leading academic institutions. Today, he will share his invaluable insights on science, design, and implementation of effective rainwater harvesting systems. Sir, we are really honored to have you with us. You can go forward with your presentation.
Yeah. Thank you very much. How do I get there? Can you hear me?
Yes, sir. You can do the sharing. You can share your screen from below.
Yeah.
And you need to, yeah.
Now, when I
Yes, sir, we can see your screen. You just need to click on from button.
see now, my
Right. Yes, sir,
approach
we
to
can see you.
I
can see
don't
the screen.
like to use the word rainwater harvesting. I would like to use the word water conservation because it is always the water which we get, we make use of it. We recycle that water and we store that water. These are the three factors. Of course, there are engineering details and experts, design experts are available who can make a tank, make a filter, make a this thing, everything they can do it. But we are at the end of the day dealing with rains, which supply us with water. So if you see, the rain is the basic thing of the really knowing which area you fall into and whether your rainwater system is going to be applicable and whether that water system is going to be useful and sustainable. So like if you see the monsoon patterns, of course, we all know it, but I just shown it as this thing that we have a southwest monsoon and then we have the northeast monsoons. The vigorous one being the southwest monsoon, which has a wedge of the Sahyadri, which really stops this and we get the rainfall on the strip area and above that area. Now, the months also we know southwest is June to September, northwest is October to this. Now, what are the factors which affect the monsoon? One is the El Nino, what we all hear about nowadays, the Indian Ocean dipole, the jet stream flows. What is the importance for this is the agriculture development, water resources, economy, and this. This is a map of India I given, which shows an average rainfall. So we really know whether yes, at 1100 mm of rain, but then there are some areas which is where there are 3000 mm of rain, especially in the Konkan area. But most of this area runs off because of the geohydrology of that place. And that is why they run into problems. And as Rosni showed one slide about the Talao in Sawantwadi, now that was the need of the day or the way of living in those days. Why those talaus had all temples around it, if you remember. All the old talaus had temples. And every year there used to be a jatra. In Marathi, it is called jatra, means a feast. That was actually a Shramdan. So all the people from neighboring villages used to come just before monsoon, do the desilting by giving their services and desilt the whole pond. So because the pond will lose the volume by run of silt being carried into it, then they'll have a feast and everything. And that's how each villages used to have their turn. And that is how they really conserved water to begin with when they had nothing else but their hands. So now we see the diminishing rainfall pattern since 1950 till 2021 days. So if you go to see some of the areas, the number of rainy days have started going down. And in between now the rainfall has again started to fill up because of the change in climatic conditions all over the world. Now, when we talk about rainfall, we talk about hydrology. Hydrology is the movement of water on the surface of the earth. So when we talk about rainfall, we have to talk about the rainfall. It's not only how many inches of rain it rains, how many inches it rains. We have to talk about rainfall intensity. We have to talk about rainfall duration, that how long does it fall, and rainfall distribution or frequency of rainfall. So we have to have this IDF from which we have certain curves which are made out, and we decide what is the peak rainfall and how the the system must be designed for the peak rainfall with number of rainy days. Then we have to study the soil type to know how much of infiltration that soil will be able to take. Like the most of the Maharashtra area and South India has got hardly any soil cover. And there is a rock layer which are very volcanic rocks, which are very compact and unfractured. So that is why the percolation rate over there is very less, and we have a chronic drought in this particular area. Then we have to see the catchment characteristics, that from where the water is coming, what does it carry with it, and what is the watershed, what is the area from where the water is being transported, what is the quantity of water what will be coming there. That will depend on the slope, it will depend on the soil type, it will depend on the vegetation. So these are the factors we take into account. Now, for a similar rainfall with different catchment types, we have where the slope is almost convex or little steep. There is more runoff than percolation. Whereas in a trough-like thing or a basic sunk-like thing, we have more of percolation than less of runoff. So these are the factors which will really decide that wherever I'm going to implement my rainwater harvesting system, have I factored all these things into designing my system? Otherwise, most of the places, it remains on paper. Nothing, the positive results, we don't see it. So now if you see, the water used by humans is hardly 0.3%. And most of that is from the groundwater we are taking. So that is why it becomes very important that we don't fall under the water stress, which is due to global warming, overuse, over demand, pollution, and non-sustainable domestic use. So for that, what are the main causes of stress is high demand, low supply, and bad quality of water. So now when we talk about rain, we must also understand one thing, that I made a bore well. Like I remember when I started working, we used to get water in Mumbai by 100 feet. Now today we get water after 250 or 300 or 400 feet. So that is something called recharge of the ground naturally. What happens naturally? Forget the urban scenario that I'll talk later on. So when the water starts percolating through the soil, it goes through the soil layer, then weathered borum layer, then it keeps on slowly going down along the fracture and joint planes. Now, if you see, hardly about 100 to 200 feet, that water gets filled up in days or in years. But if you go down 300, 400 feet, it has taken about 200, 300 years to go there, to reach there. And the ones which are 1,000 feet, what we find in Gujarat and North India, they are more than millennium it takes to go down. So actually, when we are talking that I got a borewell, I'm using, we are actually using our children and grandchildren's water right now. So it is our moral responsibility that we recharge these layers rather than have temporary solutions of putting in a tank. And for how long a tank will work, that I'll come on that. So now we have to, what is important as for me is geology and groundwater. These are the two factors which makes a difference in really replenishing the natural resources, what we are best, the nature is given us. So we have to see the complexity of geology, we have to understand the hydrogeology, and it becomes the basis for all geology, groundwater investigations. So we talk about movement of water. So when it rains, it starts going down, then there is a runout, then the impervious layer is there, there is infiltration, then there is percolation, then there is recharge. Then so infiltration is the downward entry of water into the immediate surface so that other materials get it. Percolation is the vertical and lateral movement of water through the soil by gravity, and recharge is the groundwater supplies that are replenished or recharged. Now, if you see the section of the ground below this, we have a soil, so that the soil also takes up water depending upon the porosity of the soil and depending upon the type of the soil. Below that, there is a fracture zone, and below that is your rocky area. That is called your water table. So if you see, this is the water table. The area on the top is called weathered zone, which is a weathered zone, what we normally get water from in open wells. Most of the open wells had water from this weathered zone. Then we have phreatic zone where the groundwater occurrence really starts. And the water is that found in unconnected pores, because most of the part of India and South India are, and even in Kashmir and certain areas, you find that they are volcanic rocks or metamorphic rock, which are very solid in nature. So, and unless the pores, the fractures are connected, the water cannot go down. So the key aspect of the groundwater, what we always see is that groundwater occurs as a result of specific geological conditions in combination with hydrological conditions. Aquifers exhibit porosity, that is the capacity to hold the water. Aquifers exhibit permeability, that is the capacity to transmit water. The groundwater which flows down is called hydraulic gradient, that is from high head to low head. The flow occurs as seepage or matrix of flow or fracture flow or both. Groundwater flows from recharge area to discharge areas. The aquifers may be confined or unconfined. These are the type of aquifers. Open to the atmosphere pressure, sealed by an overlying impermeable layer. These are the definitions for these two layers. Groundwater chemistry changes naturally due to the rock-water interactions in the aquifers. There are a lot of places where we have a fluorosis, where the fluoride really dissolves into this. You go to Bangladesh, there is a lot of arsenic in the water because that is there in the bedrock, in the soil in that area. So that changes the chemistry of groundwater. So the groundwater management requires reliable aquifer characterization. Now, this I spoke about what in aquifer. It's a lithological unit or a combination of lithological units capable of yielding water to be pumped or in springs. Aquifer can cut across formations of different geological units. As I said, the type of aquifers are confined aquifer, unconfined aquifer. And there is something called a spring, which is a place where groundwater naturally comes out, like we call it jara in our area. So what are the properties of aquifer? As I said, is porosity. When you want to know what is the aquifer behavior going to be, we have to find out what is the porosity, what is the specific yield, how much of this aquifer is going to give me water, what is the specific retention, how much of this aquifer holds back, what is the storage capacity, what is the permeability, transmissibility is how fast the water flows through that, and storativity is the coefficient of storage in that particular aquifer zone. From this, the groundwater provinces of India have been identified. And we find that northern mountain zone, Indo-Gangetic zone, and Peninsula Indian. So if you see, majority portion is Peninsula Indian, what has been covered as far as the groundwater importance is formed. Now, anything which is natural groundwater, natural cover is the percolation rate is almost about 25%. The runoff is only is also 25%, 10%, and the shallow infiltration is 25%. But when that 20% of impervious surface is made, when you're in village, then some concrete road comes up, you make a patio or something, then the deep penetration becomes less, shallow penetration also becomes less. And when you make more impervious surface, the penetration becomes almost to 10 to 5%, and most of the flow keeps on running. And that is what we find in city as the stormwater runout, which really floods the scenario in the city. So now to overcome all this, what do? We have to have a water security plan. So what is water security? Water security is the capacity of population to ensure that they continue to have access to potable water. Water security also means addressing environmental protection and negative impacts of poor management. So like when we talk about this plan, we have to identify the source is the surface water, rainwater, groundwater. And accordingly, we have to do the yield test, find the quality, quantity, decide what are the methods by which we can enhance the quantity of water in whichever form we are getting. So rainwater harvesting, as Rosni said, it's an age-old system. There's nothing new, and it is not a technique. It is not a technology, it's just a technique. It just captures the runoff from roofs, captures runoff from local catchments, seasonal flood. It can catch, or it can conserve water through watershed management. So if you see the element of groundwater, rainwater harvesting, we have catchment surface, gutters and spout. These are most of the things Rosni has covered, but we can just have a look: filtration, storage tank, delivery system, and treatment and purification. So the catchment is the surface from which we saw all this thing. It will be reiterated. We can just have a look at this slide for a minute, and we can go to the other thing, because what if I keep on talking on this, it will be a repetition for no reason. Now the factor which affect the movement of water in soils. So the flow, the type of flow influences how much of water is going to move in the soil. So the second is the soil surface condition, the land use, vegetation cover, roughness, cracking. Then influencing factors are mechanical processes, reuse, organic matter, antecedent water, chemical activity, biological activity, and subsurface condition is the soil hydrologic group, texture, porosity, depth, all these factors, and hydrophobic. Then all these factors come into play as far as the infiltration of the water is concerned into the subsurface. And that is what really recharges the water table. So if you see that, to begin with, the standard classification of soil, what we find is gravel, sand, silt, and clay. Clay is the finest. So the size of the clay particle is 0.074 microns, whereas sand is the biggest particle, 0.5, and we can get also. So depending upon what sort of a formation, the type of soil we have percolation rate depending upon that. And this is what is showing how much of percolation is happening. So for that, you can plot this into a triangle, this thing with 100% sand, silt, and clay from your geotechnical analysis report, lab report of soil. You can get these percentage values for everything and see where that dot comes. And this will tell which are the soils which are suitable for percolation of water. So this will be the main thing which will decide how a design in whether this site is suitable for percolation in shallow levels or we should go for something else. Now, below the soil, we get rock. So the rock also are different type. So they have vesicles. Vesicles is when the gas bubbles escape during the volcanic activity, they form holes. So they are the vesicles. So though they are not of any use, but then they allow the water to go up, down to a certain level. Then we have solutions and cavities and limestones. Then we have space in grains in sandstones. Then we have space between conglomerates and fractures in granite. So these are the places through which the water recharge can take place. And this is a schematic diagram of this kind of formation, what we get, we tell you. And in basaltic terrain where we live, we find that we have a borewell which gives a lot of water. We have a borewell 10 feet away, it gives no water. So why this is happening? So that is happening because of the surface geology. So where there is massive this solid formation of rock, and you dig any amount, you'll never get any water. And where you go into fracture zone, you look at. So what is important from this is you must have a geophysical report. Geophysical studies you have to carry. So what are the studies we do for site data assessment of water harvesting sites? So we go for published reports, geological reports, groundwater reports, soil survey, rainfall data, topographic maps. Then the field irrigation, do we test pits to do recharge? How much is the recharge capacity in the ground? What is the borehole construction, monitoring well, geological soil information, groundwater information, and ecological information. Now, all this information will come in the form of digitization of the base map. So the base map will be site data. On that, we have a satellite data, field data, and a topographic data. So we'll have 3 layers over here. From satellite data, we can have a land use land cover map. Then we can have a existing structure map. From field data of we can have soil map, and all these things together will have intersect with land soil layer with runoff number of the soil and rainfall data. We'll come to know what is the runoff potential of that map, and we can classify this into runoff potential area. With all these parameters, what you find, contour map, triangulation slope map, we can find a suitable site for rainwater harvesting structures. This is the methodology or algorithm which is applied by all government geological bodies for deciding any rainwater harvesting sites. So for these are the layers what we are talking about. These are the information of each thing, like this is soil layer, or this is slope map, or this map. And then when it is superimposed on everything, then we can get areas where the potential sites for possible recharge is possible there. So we go to any village or any work when we have to do this, we have so much of data just into one sheet. For each village, we get all this information and we prepare this groundwater security, the village water security plan, and that will include all these factors. Now, the easiest thing to make in non-urban area is having a check dam, having bandaras, gabion structures, gully, like contour terracing, bunding. This will not only increase slow the flow of water, but it will also keep on enriching the water table in that area. Now, when in Kashmir and all that, there are a lot of streams. So I was called by the Indian Army there for one simple thing, that in that area that is just on the LOC, there are a lot of streams. The villages in Kashmir, they like to live in the hills, and they stay anywhere in the hills. And that source of water is only this coming through the ground. Now, this water is basically being fed with glaciers which melt. Now, because of the global warming, the glacier melt, melt stops by, it gets over by February, March. Earlier, they used to get water till June. So their pits where they used to collect the water, they become dry. This is how they used to collect the waters. So then this is how we used to get there. So sorry. So there is a method by which we can develop this particular stream which has gone underground and boost up the water resources and bring it back to, even though to a certain depth you have to go, but they are able to again have the water from the similar source. Now, when you come to the city area, it is very simple and very clinical to do this work. So if you see, this is the plot of land we have. So it has got terrace catchments and it's got ground catchment. So as terrace, obvious thing is you have to, what is the conveyance of water? That is through PVC pipes or half round pipes or something. We allow the roof water or terrace water to go down. So that we have collect into one chamber. Then we have first flush is like 2 ball valves they have, which is one valve is open and one valve is closed, which goes to the system. The open valve throws the dirty water outside for a week, and then the filtration, then we hold the water, and then we recharge the well. Now, this hold the water, why it is required? Because see, it may rain at a very high rate or at a particular rate, and your borewell has got a capacity of taking, a little less. So suppose let's put it in numbers. Supposing you are going to get 5,000 liters of rains in 1 hour, and your well is going to give you 500 liters of water in 1 hour. So whatever water you are putting in the well, it will start overflowing. So the efficiency of this rainwater system, what we are spending for the whole thing, is pretty low. So that is why the sizing of this structure, the size of the tank depends on the catchment, peak rainfall, and then what is the yield of this well, existing open wells, what we have, and then we decide the size of this holding recharge well pit also. The overflow goes to the recharge pits and all that, which is basically the percolation in the soil. Now, percolation into the soil also is not unlimited. It is very limited. Like any open grounds in Mumbai, if you have seen it, once it rains, the whole Maidan or everything starts, soaks everything. And after 2 days, that is standing water over there, though it is a natural soil. Why that happens? Because the soil reaches a wilting point, beyond which it doesn't allow the water to we release that fast into the substratum, and then the percolation rate really decreases. So these are the things we have to have more in numbers, and the water which goes into this will be able to reach only in the soil. So we will not be able to retrieve this water, but recharge the shallow aquifers in the area what they are. So now the question comes, should we store the water or recharge the water? Now there's areas where the total rainfall occurs, most of the areas in India where the rainfall occurs in 3 to 4 months. So like for another remaining months, we have to store the water, which is not really possible because the amount of, like today in a society in India, say they require 10,000 liters of water per day. Then we'll require a water of 300 days considering 65 days it's rain. So then that means it is how much of water. So look at the quantity of water we'll have to store. What let's calculate what is the cost of making such a huge tank. Will otherwise this water what you collect in a small tank and all will get over within 10 days after the monsoon. So it is always feasible in these areas to use rainwater to recharge the groundwater rather than to store. Storage can be there where like in northeast area or in or areas where the demand of water is not that high, where the population using that water is not that high. These are the areas they can do that. So designing the and sizing the rainwater system is segregate the roof and terrace catchment runoff, calculate the runoff of various catchments, calculate 1 day runoff from each catchment, calculate the recharge volume required for manual aquifer recharge. Now this recharge volume is what I said about the tank and the size of the pit for the recharge borehole. Evaluate the soil properties, quantify the soil rock material mass properties, select geological safe sites for manage aquifer recharge, and filters of any type. It will not remove clay particles, which is very fine. So that is why you must not depend upon filters that it is going to do my work. Most of the time, the failure of rainwater system is the choke up of the filters of the system what we have made. Now, these are the basic pictures what we find in city. These are the first flush valves, which can be done, they're done on the, this is the system instead for a structure which is already there. So you can't keep on digging everywhere. So you take conveyance pipe like this. This is the holding tank, what I say. These are the basic chambers. So major cost of rainwater harvesting is the construction, the civil cost, because these pipes have to be really dug up and done there. So it is always advisable this work to be carried out when the building is being made. After the construction is done, then we have to take pipe like this to avoid this digging up on that on the ground and the cost which is required in that. The places now today's design, we have a basement parking or a parking, so where the pipes are coming down. So how do you do that? So you can just have a hanging pipe and take all the water outside. Like you have a farmhouse, but you don't want to make it dirty by looking a pipe coming down. So you can put change. So it'll beautify the thing and it'll do our work also. So now this is the basic way to find out how much of water will be collected in the rainy season from my area. So you take the UF area, annual rainfall of that area, and the coefficient of friction depending upon the type of catchment surface what you have. These are the examples how the systems have been done in execution. Now this is one downtech pipe where they all been joined together. This is a bypass valve pipe. This is the first flush valve, one valve, ball valve. So when the first rain, they close this valve, the dirty water goes up from here. Then they open this. This is the filter, which is made of SS304, and this goes to tank or to recharge borehole. There's similar thing, grid filter, like we make filter with gravels and everything, or we can have a filter in a. So depending upon the site, the dimensions what we is available at the site, we design the type of filtration units. Now holding tanks, you can have an RCC tank like this, or if it's a small household, you can have this cement hume pipe rings and you can put it down. Now these are the recharge well, how it is, one bore well is already there. They dig up around that. Around that, they put this wire mesh. Before that, they make holes in the wire mesh so that the soil doesn't go through here, because this is the most critical thing. If any soil goes inside this bore, this is a borewell of say 6 inches diameter or 150 mm, and there is a submersible pump here of 145 mm. So little bit of something going inside, it will choke up, not only choke up the borewell, but even the pump will get stuck and it will not come out. So this is very critical in doing this work. So this, if you see in sequence, it looks like this. Now, soakways or dig board shaft. Now there is heavy soil, like we were talking about in Mumbai, like Roshni madam was talking about Dharavi. Now, Dharavi and BKC and all these area have got marine clay, Lokhandwala area in Andheri. Now, this clay doesn't soak any water. So we have to have a negative well. So for that, what we have to do, we have to dig a hole in this formation, seal the top layer, and then allow the water to go into the fracture system what we have. This helps in dewater. Like so, in a society where we did in Bandra, so there was a lot of water coming from side the buildings and all. So there was water getting filled up here. So in this stormwater drain, what was already existing, we had 2 or 3 bore wells, and then recharge structures made around it called boats or soakways, which took care of the whole thing. Then this is the basic thing all architects and all designers always must incorporate in this. I'm sure they do it, but this is one thing I'd like to show. And this is the other thing, you have a farmhouse, always make a road, but then make it like this with a small, porous pavements, live in between the green belt and all. It looks nice also, or have gravel bed going through it. It looks good also aesthetically. Now there is sustainable water management solutions for the urban flooding. One is the green structures. I think the architects, this is mainly the architect subject, what they can design the whole thing. The green structure involves using natural processes to manage water. Examples include roofs, rain gardens, permeable pavements. This system absorbs rainwater, reduces and help replenish groundwater supplies. You do rainwater harvesting, we already spoken on that. Sustainable urban drainage system. You must have sustainable drainage system like you have a say 30, 40 acre plot where you are making a number of buildings. So we have a lot of stormwater drains in that area. So what we do in the stormwater area at every interval, depending on the runoff which is coming to these drains, whose job is basically to throw the water out of that plot. So in these stormwater drains, we put lathis, tandoor stones, at every 30 or 40 feet or 50 feet, depending on the quantity of water. Now, supposing the depth of this, the stormwater drain is say 2 feet, then this stone should be about 1 feet. So as Rosni said, pani ko slow karna chahiye. That is what we are doing. Plus, that stone will also block the silt going over further over there. And after this stone, what we have put, the slab, what we have put, we must have a recharge pitch in that area. That is that bottom area for about 1 or 2 meters must not be concreted and should be dug up and filled up with filter material or brick mats. So like that, you must have it in a series of this. This is basically something like a check dam of what we do it in city area. So like this, we have area. The other thing what we can make is swales, detention basins, and construction wetlands. So then wetland restoration or improving the drainage infrastructure. Now we must also see why the rainwater harvesting system is failing. Now, even though we have been talking so much, but then we are hardly quantifying it. Now, the first reason is silt and sediment choking, which is really making the system non-workable. Second is the improper system sizing. The tanks are often sized incorrectly for local rainfall. The catchment surfaces feature toxic materials like asbestos. Pipe diameters restricts heavy storm runoffs, and poor slope angles prevent the water from flowing. Poor site and soil selection, not selecting geologically favorable sites. When there is a high water table, that is, I say anything less than 5 meters, the water will not go in that area. There will not be any recharging possible in that area. They're neglecting the flush diversion because that during the first monsoon, 5 days, 10 days, maximum dirt comes there. And if you don't have the system, it goes and chokes up everything. And then we have people hardly after monsoon, they are supposed to close that wall. They don't do it because the terrace is still open and somebody has a party or somebody washing that floor. That water can also come into this system. So lack of regular cleaning and this maintaining is required. and you have to take care of biological contamination. There are a lot of birds and bird dropping and everything falls on that. These are some of the reasons why the rainwater harvesting flops in the earth. So I think if you do all this, this is the, we always talk about hydrological cycle. Now I talk about hydroillogical cycle. So like, it rains, we come and sit, we go for a picnic, stand with the umbrella, then we go to sleep, then there is a drought, we start looking for water, then we start spreading awareness, then we are concerned for other things, and then we panic and call 911. This is what happened. It keeps on every year. So instead of this happening every year, we must start, get together and put our act together and do some water conservation method with water recycling and water reuse. Thank you very much. Okay.
Thank you so much, Amar sir, for that highly informative session.
No, I could have shown you my 125 slides.
We will have another webinar for that, sir.
Okay. No problem.
Thank you so much for sharing your invaluable practical experience in groundwater
If anybody has
management.
got any queries, I can answer it. It
Yes,
depends on your
we
structure,
have.
your seminar structure.
Yes, we have a question and answer session in the end. Meanwhile, if you want, you can answer them in the chat box. There are a lot of questions, so you can answer that over there, or else we can have a.
You can take at least there are just two questions from one person. Maybe we can take it all
Yeah,
of them. They are
I
very
think
pertinent.
Chaitrali has asked a lot of questions. Ma'am, if you want to ask anything particularly,
I
how
think like
worthwhile is
what I say,
recharge?
let the other two people also speak, and let's have a collective thing because they're all interconnected.
Okay,
No,
okay, great. Okay, so we move on to our next speaker, that is Mr. Ayush Bisht. He's a blue evangelist at Retas Enviro Solutions Private Limited. He is a sustainability professional with over 11 years of experience in environmental solutions, specializing in green infrastructures such as biowalls, landscaping, and rooftop organic farming, freshwater management, and modular rainwater harvesting systems. Currently serving as a blue evangelist at Retas Enviro Solutions Private Limited, he closely works with architects, consultants, EPC contractors, and government agencies to deliver sustainable water management solutions across a wide range of infrastructure, industrial, commercial, and institutional projects. It's a privilege to have you with us, sir, today. I think. Hello.
Hello.
Yes, sir. Over to you. Thank you so
Yeah,
much for joining us.
sure, sure. Can I just? I'm not able to open my camera, I guess, but it's okay. Yeah,
Okay, you can start sharing your
yeah. Now I
screen.
can. Thank you very much. So let me share my screen first. Thank you very much, first of all, for giving me this platform where we are discussing about the purest form of water, which we call rainwater. I hope my screen is visible.
Yes, sir, it's visible.
Okay.
You can
So
do
before
full
moving
screen.
forward, I just pardon.
Can you do full screen, please?
Yeah, sure.
Yes,
Is this
perfect.
full
Thank
screen
you.
now?
Yes, sir, yes.
Okay, okay. So before I start anything, Rossi ma'am and Amarjyoti sir, fantastically describe about the rainwater housing practices, about the how we calculate the rainwater, what is the importance of aquifer, what is the importance of soil strata. So I don't invest more time in that. I just want to say one thing: ki a building is just not a consumer of water; it can be a producer, recycler, and recharger of a water as well. Why I'm saying this? Because what happened during monsoon season, we are seeing a flooding issues or waterlogging issues everywhere, and during summers we face the scarcity of water. So here I just want to present one thing in Ritas. What we are doing is we are adopting a smart rainwater harvesting practices so that we can save the purest form of water either by recharging it or either by store and reuse it. So we provide consultancy, we provide calculations, we do executions as well. Why I'm saying it is because what happened, rainwater harvesting can be done in many ways, right? You can store and reuse the rainwater. you can provide percolation spit, you can recharge the groundwater, and you can simply provide the bioswale as well. And same thing that we are doing in this. What issues we are facing in our conventional method is the improper maintenance that Joshi sir also mentioned it. If you are not maintaining our system, then maintenance the system gets chopped, and by the time it will not give us the result that we are expecting from that system. So there are two kind of conventional rainwater system that we usually that I usually see in many of my sites. One is when we are recharging the water, and second is when we are storing the water. In which in both the system we use filtration bed like boulder, gravel, and sand. And what happens when we are not maintaining the system? The system gets chopped because of the improper maintenance. So what is the solution for that? The solution for that is a modular rainwater housing system. What and so I just want to spend 2 minutes in this slide. So if you see in my left hand side, this is a conventional rainwater system in which there is a desalting chamber and there is a rainwater housing pit and there is a provision of borewell inside it. So what happen in conventional rainwater system? Water comes from a stormwater line and there is a provision of backfill wall where first level of sedimentation happen here, and then water goes into my recharge pits, right? And there is a provision of boulder, gravel, and sand, which we call a filtration medium. Water goes into this, and with the help of slotted pipe of borewell, water directly goes into an aquifer. But the problem is, it is not when we design this sort of pit, we are not able to design it with proper capacity, because if you see the blue sort of color, this is the only the effective volume that we get. So in case if I'm making a tank of 100 cubic meter, in conventional we just getting a holding capacity of 60 cubic meter, because lot of area is taken up by the filtration media and few area is taken up by the freeboard area, which we take from where we take an inlet in our system, which we call an invert level. And then I hope I am audible to everyone. Hello, hello.
Yes, yes,
Yes,
you are.
yes.
Please go ahead.
Yes, yes,
Yes,
yeah,
Sameer.
sure. So what happened basically in this sort of system, we get less holding capacity. In modern days, there are new technology that we call modular rainwater system, and many people are using it, especially industries. All the redevelopment of airports, railway stations are using opting the same technology. What happened in modular technology? We don't require the filtration media. We use a filter which we call a microfilter, and there is an SS40 mesh inside it. So what happened when water goes into a desalting chamber, the first level of sedimentation happen here, but the small particle from 60 to 90 to 600 particles of micron filters in this filter, and then water goes into this tank. And this tank is not made up of any RCC or not made up of any brickwork. These tanks are made up of recycled polypropylene modules. So here what we are using is we are using recycled waste material, waste plastic, in order to create our tank. So while making a tank, we are doing two things. One, we are doing rainwater harvesting. Second, we are using recycled waste material, recycled waste plastic. The another advantage of this modular system is these system are wrapped with geotextile. I show you a small video about it as well, so that you can get a better idea. So the benefit of the another benefit of the system is when water goes into these tanks. So if we don't require filters and media, so our bore will not get choked easily. First thing. Second thing, if you see this green area, this is a backfilling of a soil. So the top surface here we can utilize the way we want. So basically, where there is a landscape area, we can install our system there also. If there is a road area, we can install the system there as well. If there is a parking, if there is a paved area, we can install the system there as well. So we are designing a system in such a way that you can get optimum utilization of space as well. Now, another thing is maintenance. When we are trying to maintain our conventional system, we just need to pull out all the filtration bed like boulder, gravel, sand out. Then we need to clean it. Then again we need to put inside it the tank. But what happen in modular system? We don't need to clean the tank because my tank is covered with a geotextile membrane of 400 GSM. So I just need to clean the filter part. So it is always easy to clean a small system as compared to the big tank, right? And here in our in modular tank, we are getting a holding capacity of 96%, which means if we, in conventional, if I'm making a tank of 100 cubic meter, we just get an effective capacity of 60 cubic meter. But in case if you are making a tank of 100 cubic meter here, we are getting a holding capacity of 96 cubic meter. The holding capacity is just double. And another benefit of modular technology is we do quick installations. The maintenance is almost negligible. We design the tanks in each and every shape. So, sir also mentioned about the space constraint, right? So we have a space constraint in modern day technology, modern days जो भी हमारे design बनते हैं buildings के in that. So we are able to sort out theirs as well. And when we go for any IGBC rating, any GIRHA rating, or any LEED rating, we get extra points for that as well. We get points for rainwater harvesting, and we also get points for using recycled material in it. And when it's come to cost, the modular technology is 15 to 20% cost effective as compared to any RCC structure in the world. And these are the pre information that we required while we designing the tanks, like what is the site location, what is the percolation rate, जैसे जो हमें तो सर ने भी जो mention किया था, what kind of structure we require, do we want to recharge the water aquifer, do we want to store the water and reuse, because what happened, most of the industries required store and reuse facility, but most of the commercial building and residential buildings required to recharge the aquifer. What is the invert level, what is the peak rainfall data. So on the basis of this information, we can design the systems. This is a typical diagram of a recharge system where water is coming from the desalting chamber, it goes into a filter, then it goes into a tank, and by that, with the help of borewell, water goes into an aquifer. So I just stop this slide and just want to show a small video. Can you play a video, small video here? Hello?
Sorry, sir, yeah.
I am saying, can I play a small installation video so that you can get a better
Yes,
idea
yes.
how modular technology works?
Yes, sir, yes.
Just give me 1 second. So this is the video that this tank we install in Gurgaon Sona toll. And I will explain you the major problem. This toll faces a major problem of waterlogging. So we just try to solve the problem and we just try to minimize the problem.
गांव घामडो तहसील सोना जिला गुड़गांव की जो एक टोल टैक्स के पास की जो ये जगह है, बरसात के टाइम पर पहाड़ियों का यहाँ पे बहुत ज्यादा पानी इकट्ठा होता था, जिससे जाम की समस्याएं बनती थी। खेतों में पानी जाता था तो फसलें खराब होती थी और बहुत ज्यादा जल भराव हो जाता था, जिसमें एक बार पहले यहाँ पे एक हादसा भी हुआ था जिसमें एक बंदे की जान भी गई थी इस वाटर ट्रेन में पानी भरने की वजह से।
So I just give you a brief about this project. So if you see this project, this toll is in depression. तो what happen जब बारिश यहाँ पे होती है तो एक तो टोल में हमारा बहुत ज्यादा पानी इकट्ठा होता है, यहाँ पे फ्लडिंग के हमारे इश्यूज होते हैं, वाटर लॉगिंग के इश्यूज होते हैं। अनदर प्रॉब्लम इज व्हाट, जो पीछे के हमारे जितने भी गांव हैं और जितनी भी रिजनल सोसाइटीज हैं उनका ओवरफ्लो भी यहीं पे आ जाता है इन दिस ड्रेन। सो एनएचआई मेड दिस ड्रेन with the assumption जब भी मेरे टोल में पानी भरेगा तो आई विल डायरेक्टली कनेक्ट द रोड टू द ड्रेन। सो रोड का पानी ड्रेन में जाएगा, ड्रेन से पानी आगे चला जाएगा। बट व्हाट हैपन ड्यूरिंग मॉनसून, जब 1-2 घंटे की बारिश होती है देन इट्स ओके, बट व्हेन द जब बारिश हमारी लगातार होती है तो व्हाट हैपन, पीछे के जितने भी ओवरफ्लोज हैं, जितने भी घरों से, बिल्डिंग से, वो सब इस ड्रेन में आ जाते हैं। तो ड्यूरिंग मॉनसून व्हाट हैपन, दिस ड्रेन इज ऑलरेडी फुल, सो सड़क का पानी ड्रेन में जा ही नहीं पाता है। तो here we do a back calculation, we get this area by one of the NHI contractor, and we do a back calculation and we create a 520 single KL tank here with the help of 5 borewell inside it. So we design a system in such a way we take water from this drain directly into desalting chamber, microfilter and tank, and then when the drains get empty, the road water goes directly into a drain. So we try to follow this design here.
Radis Enviro's team arrived, armed not just with tools, but with vision.
So the first step is borewell and the second step is excavation that we do here. After excavation, we just compact the base. Then we made the base with the help of stone chips and sand, and we just required 4 inches stone chips and 4 inches sand just to make a base, or you can say a kacha base. When the base is prepared, we use this geotextile of 400 GSM. The benefit of this geotextile, first of all, we lay this geotextile at the base, then we wrap the whole tank with the help of same geotextile so that बाहर का कोई भी चीज पेनिट्रेट करके हमारे टैंक के अंदर ना आए. And we made the tank with the help of these modules, and these modules are made up of recycled polypropylene. And the good thing, these modules can take load up to 30 to 45 ton of vehicular movement. So whether there is a road or where there is a fire tender movement, these tanks are well enough to take all kind of load. Once we assemble our modules, we joined all the modules together with the help of these clips so that my tank get intact. And if you see, that tank is ready, but we don't require any RCC structure or any bridge structure. So what we are doing in modular technology, we are replacing RCC tank and brick tank with the help of recycled polypropylene modules. We don't require any RCC wall. Now we simply do the backfilling. Backfilling we do layer by layer. Then this is the desetting chamber and filtration chamber. These are our microfilters. The body is made up of FRP and there is an SS304 mesh inside it. So whenever water comes from desalting chamber to my microfilter, it filter and the clean water goes into my tank. If you see this area, so the back side is desalting chamber, then this is microfilter and this is the tank, the green area. So the top surface you can utilize the way you want. This is the SS004 mesh I'm talking about. So whenever you want to clean the filter, you just need to pull out the this SS304 mesh, just clean it with the jet or pressure, and then just need to put it back. That is the only maintenance that you require. So we don't eliminate the maintenance, but we try to minimize the maintenance in modular technology. So here, when we visited this site, the water logging take times for more than 48 hours, but we minimize up to 8 to 10 hours. Let me just go to the main slide. This is another picture of Faridabad Agra highway where we install modular tanks under the flyovers. And then one more interesting thing, with the help of same modules, we can create a storage tank also. So where there is a requirement of storage to store rainwater, we can use the same system by just change few steps in installation process, and we can use the same system for the storage as well. So this is a storage tank that we done with Asirvad pipes. This is also with the help of modules we can create a bioswale or ecological channel as well. And in Delhi, we all know borewell is not allowed by Delhi Jail Board. So here we can also create the percolation pit with the help of same system. This Chandigarh PGI pics, there are few pics. We also use SDP liner where we are installing our tank between two boundary wall and a basement wall. This is a picture of Andaman, where is the upthrust, where is the high water table. So we can install our system there as well. We are also coming up with working on this technology on a higher level. We are making a tank which can take 60 ton of vehicular movement load and which can go 6.5 meter deep, because these days we find invert level so high. And we are also working on dashboard, so where you can check the impact, what impact you are creating. So we are introducing a dashboard system which will give you a rainfall trends, which will also give you how much water you are harvesting, how much water is in your tank. So it will give you all get in in your fingertips. Yeah, that's it from my side actually. If you have any questions regarding that, so you can go ahead.
Thank you, Ayush, sir, for that presentation and showcasing innovative approaches towards sustainable water management and rainwater harvesting. We will be having the question and session at the question and answer session at the end. So,
Sure,
meanwhile, if you can just in the chat box, there are a few questions for you. So probably you can
sure,
answer
sure. I
them.
will.
Thank you so much, sir.
Sure.
Our final
Thank you.
speaker for today is Mr. Deepak Jain, the CEO of NEER. He is the proprietor of NEER, an accredited consultant of the Central Groundwater Authority (CGWA), established in Noida, Uttar Pradesh in 2006. With over 30 years of experience, he has worked extensively in groundwater management, availability studies, impact assessments, and the design and implementation of rainwater harvesting and in artificial recharge systems for industrial and infrastructure projects across India. He is also a registered consultant for rainwater harvesting and artificial recharge with the government of Uttar Pradesh and has served as a technical member of district technical committees on rainwater harvesting and artificial recharge. Over his career, he has been associated with more than 1,000 projects related to groundwater management and impact assessment across industries. He has prepared city-level rainwater harvesting master plans, guided nearly 3,000 industrial units on rainwater harvesting and artificial recharge across multiple states, and carried out groundwater contamination assessments along with remediation planning. Thank you, sir, for joining us today. The floor is yours.
Thank you for giving me this.
So you're not audible.
Is it now?
Yes, yes.
So thank you for giving me this opportunity to speak after a long time of waiting.
Most welcome, sir. You're most welcome.
I would say Ms. Roshni and Dr. Amar Joshi has completed my job
Oh,
well in advance, and both of them, along with Ayush Best, has covered two topics: what is rainwater harvesting, how it can be implemented.
Yes, sir.
But
so we would
but
like to hear from you also, obviously. You were
no,
also an
no, no, no.
expert in it.
I will come on that.
Yes, sir,
The
sure.
first of all, one question they have left out of your topic: why it is required?
Right.
Why it is required? Because we have our civilization of thousands of years, and water is a commodity without which nobody can survive. And our survival for thousands of years is not because of a shortage of water, but we were managing the water. Now the question is how we manage the water instead of which is otherwise going waste. So that was the question raised by one of the activists. I'm just speaking extempore, then I will come on slides. Because about rainwater harvesting, we have gone through the sufficient material. There are some queries we will discuss thereof.
Sure, sir, sure.
But the first fundamental question is why it is required. So in that fashion, because water table is going down, depleting in pan India, we have, as Dr. Amar Joshi and Roshni ji has already conveyed, that we have plenty of rainfall, and there are countries who have very 10% of Indian rainfall and managing well. So how? because there are certain reasons and there was a question before Honorable Supreme Court by one Mr. MC Mehta in 1997. How much groundwater is being withdrawn from our groundwater resources and how it is managed. The Central Groundwater Board, at that time Central Groundwater Authority was not there. Central Groundwater Board replied that we don't know how much water is withdrawn pan India. Reason being, there are multiple withdrawal agencies such as private houses, agriculture, industries, other infrastructure projects like. So it is very difficult to identify or quantify how much groundwater is being withdrawn. Then in 1997, Honorable Supreme Court formed a authority, namely Central Groundwater Authority under the Environment Protection Act. And this authority was in combination of two ministries, Ministry of Environment and Ministry of Water Resources. So the board of this Central Groundwater Authority comprises members of both the ministries. And they issued their guidelines. How, whosoever is drawing groundwater, they have to take permission. Why this permission? Means they have to declare their water withdrawal well in advance so that mitigation measures can be developed in accordance to the water withdrawal by them. There were 4 exclusions. One is private houses, because we know what will the requirement according to NBC norms, what will be the requirement of these private houses. Agriculture, we know how much water column is required for a particular crop. Rural water supply system, the same fashion, and the defense because of security reasons. Except that these 4 exemptions, everybody has to declare what quantum of water they are withdrawing so that to replenish their requirements, what withdrawal, they have to proceed for rainwater harvesting artificially, because there are 2 aspects. One is natural percolation, another is man-made efforts. For man-made efforts, they have fixed the liabilities. So now I am coming on the direction made by Honorable Supreme Courts and Central Groundwater Authority and why rainwater harvesting is required. May I come on the slide now?
Yes, sir. We can't see your screen.
Just a minute, please.
Okay, okay.
Hello.
Hello.
Hello?
Sir, do you
there is-
require it?
No, there is some problem. My software engineer working on that. Just a minute, please. Just a minute.
Okay, okay. Maybe you can share the presentation to me and I can share it from here.
Just a minute.
Okay, okay, sir.
हेलो हाँ जी नमस्कार अरे वाह ये वाला शेयर कर चलो स्क्रीन शेयर स्टार्ट करता हूँ इसमें ऐसे करो स्क्रीन मीटिंग इसमें इस वाले में अंदर है हाँ जिसको ओपन रखो अब जाते हैं उस पे मीटिंग किसमें पता नहीं चल रहा ना ये अब हम सफारी में थे ना मीटिंग में तो उसमें तो Is it visible?
Yes, sir. Yes, it's visible now. Yes.
So this is the basically a requirement and direction given by the government of this is Honorable Supreme Court that we should come for guidelines. Just a minute, it is open for Maharashtra only. कहाँ पर स्क्रीन Am I audible now?
Yes,
Yes.
sir.
Yeah. So most of the industries are totally dependent on groundwater. Almost all infrastructure projects are dependent on groundwater as on date. Because if we go through the ancient culture, most of the cities rather were along with the river, not along with and not uh, any part of any other part where river or canal system is not there, or any tributary. So now everybody is concerned about the land or the space, irrespective of natural stream or river. So everybody is dependent on groundwater. Whereas government's water supply is also dependent on groundwater. So, and in many of the mining activities, underground mining, dewatering is required because of excavation and exploration of minerals and all these. Agriculture is also dependent on groundwater. So everywhere groundwater is required, whereas replenishment system is somewhere blocked, because in one side we are exploiting more, natural recharge is less, and simultaneously there's no we are regularly reducing the recharging modules, recharging space, recharging land. The therefore this Supreme Court directed to Central Groundwater Authority to make guidelines and prepare a scheme in which water management and retention of groundwater level may be maintained. Groundwater depletion in every part of the country can be controlled. Actual requirement of water exploit from groundwater can be assessed, and it is mandatory for industry, infrastructure, and mining projects. So there are certain these concerns by which Central Groundwater Authority was meant for, and they were directed to maintain all these things. Now, since the applicability of CGWA guidelines is pan-India, whereas some of the states are holding their own authority, but apex body is Central Groundwater Authority. This is the groundwater situation. Out of the total many, this red zone is a overexploited area. So you can see where the water is being exploited more than natural recharge. The condition, now we come to the part of the NOC of Central Groundwater Authority, which I was discussing. The condition of groundwater NOC is adoption of rainwater harvesting system and development of rainwater harvesting system by adoption of community areas like pond, lakes, government school, building, laser leveling of agricultural field as a compensatory water conservation measure on pro rata basis. Pro rata basis means in some part where this overexploited area, industries or infrastructure projects are bound to recharge double of their annual withdrawal, and in safe area they are bound to recharge 50% of their annual withdrawal, so that groundwater level can be maintained or managed. These are the infrastructure projects who are mandatorily required to recharge, obtain the NOC, and then adopt the rainwater harvesting system. All these factors already discussed by Dr. Amar Joshi, Roshni ji, and Mr. Best. These are the factors why rainwater harvesting. So my personal concern about this seminar, and not concern, I will say my personal view about the seminar is we should come with one common platform, that when we are planning a, apartment or some township or something else, we should consider how much covered area we are taking off. Means on when we talking about FAR we used to take over the ground. In according to the National Building Code 1962, this is open to earth, not open to sky. Because when a plot, I have seen in pan India and most of the this you can say societies or other infrastructure projects, 95 to 98% area plot area is covered by the basements. Then we come out with some towers of percentage meet out the FAR requirements. At that time, as Dr. Amar Joshi were talking about the runoff coefficient, in that scenario, runoff coefficient will increase, but we are taking about normally 0.4, whereas it increased to 0.8 because of 100% concretization. If we see the ground situation of any of these this habitat areas, the prominent areas, like in most of the cities where apartment culture has come forward, or this kothi culture is there, most 100% plot area is covered by the concrete by way of either basement or backyard or something. Then come to road, then another side is another kothi or this infrastructure projects. So the entire rainfall moves on roads. That is the root cause of flash floods, and that is why it is stagnate at so many. Since last 2-3 days, we are looking this situation in NCR or most of the part of the country, that everywhere flash flood. Why it is so, and in urban area as well. So this is the root cause, that whatever we have designed for drain system, that is for under capacity, our runoff is much more than the required and we don't have the proper capacity of rainwater harvesting system. So for when we used to plan in new buildings, these three factor has to be considered. What is our runoff total? What is the capacity of our rainfall during peak showers, so that retention capacity of rainwater system can be developed according to the peak shower, and then only this practice can be fruitful. That is all from myself. Thank you.
Thank you so much, Deepak sir, for sharing your valuable insights. We will now move to the question and answer session. If anybody has any questions, you can ask, addressing the person.
I'm sorry for this mess up of computer.
जैन
That's
साहब,
okay.
आपका आवाज बहुत कम आता है, आपका आवाज बहुत लो है.
लो है? आपके सामने मेरा लो हो गया है.
देखिए, if you can raise the voice. Thank you.
Do we have any questions from the participants?
अभी आ रहा है बस?
हाँ जी, अब आ रहा है.
Yes, I do have a question
Yes,
to Deepak
please.
sir. Sir, sir, good evening, sir, Deepak sir.
Good evening, good evening.
Sir, in fact, this question is not related to the topic, if I am correct. So, what might be the procedure to enroll as a water auditor training in GGWA, sir?
There will be exam. They will publish the advertisement. Then they will conduct the exam. Then only it can be.
So, we need to monitor the website.
Yes, yes, yes. CW. Now it is on BHUNIR, BHUNWR.
WRs.
Yeah.
Okay, thank you.
Somebody has asked, as per SC or government, which types of buildings is mandatory for rainwater harvesting?
Every kind of building, wherever water is being collected, Now, there are two aspects. Uh, there is one exclusion in industrial aspect, industrial policy. If there is a polluting industry, they have to store water, then directly use it instead of drawing groundwater. Like one
Okay.
Jubilant company is there, you might have, because I am talking about this Maharashtra. In North India, there are a lot of chemical industry. One is this one, Bears, in Thane. I visited there. That now its name has been changed. They can use rainwater harvesting by storing they have to store the water, then consume it first by treating, then they are not allowed to recharge because there are chances of contamination of groundwater.
And
Yeah,
can I
please.
add one thing? Can
Yeah,
I add this? Any residential area,
yeah.
standalone buildings or something, area more than 1,000 square meter, I think it is mandatory to do rainwater harvesting.
It is depending upon state to state. In UP, there is 300 meters. Delhi is 100 meters.
Mumbai, it is there.
Mumbai maybe 1,000. I don't
Uh,
know. So there are this is a state this is state building bylaws.
Yes, I don't think there is a blanket law or regulation all over the country, but specific municipalities have
Yes,
made it
correct.
have made it mandatory. Like Chennai, I know for sure that rainwater harvesting is mandatory for all new buildings. And same thing in Mumbai in 2002, the regulation was introduced. That is, you in order to get your IOD/CC for building, you need to do rainwater harvesting. It's mandatory. But as we know everywhere, how rainwater harvesting is done. So it's not kind of monitored, and that is one of the major issues. Nobody is checking. It should be done on a year-on-year basis, not just the first year, but year-on-year, whether the rainwater harvesting system is maintained, etc., and so on. Because quality issues are also, happen when it is done in a decentralized manner, not taken care of, and maintenance is not done, and so on. So that is one thing. I think the second one question by Chetrali, I think all her other questions are probably answered, but she's asked about urban planning. How is rainwater urban planning done to protect cities from flooding? So, Chetrali, I don't think that there is, again, any sort of rule or overall country having any kind of planning kind of regulation or guideline in this aspect. However, there is for example, in Mumbai, we have the stormwater drain system initially, which was really designed. The brimstone system was originally designed for carrying a specific amount of rainwater. But as Deepak sir and others have pointed out, the runoff coefficients that they were planned for,
Hmm.
and the kind of this runoff that is happening now because of paving and parking and all of these things has made the flooding in every place. And one more thing I would like to add before Deepak sir makes his point is that in most of the European countries now also the flooding is happening. And for example, in Germany, they've gone for sponge cities. China also, a lot of cities are going for um, removing the pavings and making it into softscapes in order for the percolation to happen. This is deliberately being done in many cities. And I think that we should also have this kind of regulation to increase the softscapes, to have more water go down. Yes, sir.
Roshni, I will interrupt in between. When some group house, this township or something has to be developed, then they have to undergo for the groundwater permission. That is sure. If they go for groundwater permission, they have to mandatorily plan for rainwater harvesting.
Yes.
It is there. So whatever you are saying, that is applicable for individual house, not for the township.
No, she's talking about urban planning. So
For
that's
urban
what I
planning,
that's what I
that,
meant. That
that
is
for,
for, yeah.
for urban planning, if we are talking about the development of complete holistic planning, then we have to implement it. When we go on micro level, micro individual, this unit wise, then it is not mandatory. It will govern by the local building bylaws.
Bylaws, right.
May I add something? I am Engineer P.S. Virdi from Patala.
Yes, sir.
The concerning bylaws, it is fine they said cage 100 meters, 200 meters houses, but is it practical? I don't think, rather it will be practical. If it is like a lawn is there, the park is there, the rainwater harvesting is done in that place. Each house can't build a pit or something to do it. So the bylaws are equally funny, I will say that. Achha, second thing, the recharging of the water or the harvesting of the water, you can say, is we need some particular depth which has to be go beyond the drying water aquifer. Otherwise, we are polluting the our water. So those things are there. The another thing which will it was very nice. Dr. Roshni, Dr. Amar Joshi, and Ayush Bhatt and Jain Saab. So it is good thing, but our all problem is man-made problem.
Yes, 100% agree with this.
That there. For example, now the recharging, the natural rivers or canals, we are brick lining it, we are cement paving it, where the natural flora and fauna is disturbed. So the angle of slope is that much. If a animal falls in, it can't come out. If it is a normal earth or soil, the snakes are living there, birds are living there, the neolas are living there. So that flora fauna goes disturbed. A person falls into, it can't come out. The seepage, soakage system gets disturbed. Another thing, the city side. Our cities will not be flooded from the flood water, but it will be disturbed by the rainwater only, because the natural flow of the earth, which has been disturbed by our urbanization, so-called urbanization. So the natural flow is down, and the soil part has gone down. The pakka part or roads, buildings, they have taken up the area. So the rainwater comes, it goes, and where it has to go? It has to come to the roads, or it enters our houses. So these problems are there. So I don't know, we make rules, or we may discuss here the things. Now the on the ground, what happens, that we don't know. Nothing happens. So this is one of my point, but there are many things. Second thing is you can call it, they have a fashion calling green buildings, sustainability, conservation, this and that. So green building, I have seen in Patala city, they call it a green transport. What was green? That was a green rickshaw, painted green, which person could not sit properly. It was ultimately gone to its own death. So such in their sustainability, you see, sustainability, I call it, our villages are sustainable. They are living their own. They don't pollute anything. Cities are polluting more. Cities are drying water more. Cities are using it.
In fact, sir,
That's
I
it,
will
sir.
interrupt. I will interrupt you in that way. We all are. I suppose we all are technocrats. We will discuss these matter and we will be differ from one person to another person. The decision makers are not technocrats, and
Your
that is why.
voice, your voice is a little low. I can't hear it.
Hello, is it okay now? Why it is so low? So the persons who take decisions are not technical, and they have more powers. That is why all these problems have arose.
नहीं, I sometimes call के गधे घोड़ों को लेके जा रहे हैं.
One of my friends says technical decisions are taken by the administrator. Administrative decisions are taken by politicians.
Right.
Political decisions taken by gundas. That is the one step displacement is the root cause of all the problems.
Yes, you are right. I agree.
So, but what there are what I have already discussed, we groundwater, and you are endorsing my views. groundwater recharging, whatever we are discussing, this is a water management policy we have to adopt. एंड जब जैसा आप बता रहे हैं 200 300 400 मीटर की बिल्डिंग के लिए, तो हम जो उसके डाउन पाइप आ रहे हैं उनको एक टैंक से लिंक कर दें और दैट कैन बी डायरेक्टली यूटिलाइज्ड। और अगर 2 स्टोरी बिल्डिंग है तो फर्स्ट फ्लोर पे टैंक रखें, उसका फिल्टर वाटर को यूज कर सकते हैं हम। यहाँ we have done it at a lot of places. So many persons have adopted it in North India.
So I close it from my side. You can carry. The next wars will be for water only.
It is
It
going on.
started.
Huh?
It has started.
It is started.
There's already started.
But I'll make
Now
a small funny remark.
Yeah.
You know, we call there are so many rainwater harvesting experts. Now,
Yeah.
this term expert I get very scared with. Because what is an expert? He is a person who knows too much about a very small thing. So I don't like to call really depend on experts.
All my laborers have become an expert of
yeah, agreed. That is there.
In this Hamira, you might have heard about Jagatjit industry. Vidhi Saab?
Yes, I'm listening.
There this distillery, Jagatjit industry in Hamira, Kabutla. They had polluted groundwater up to the extent of 1 lakh hazen, black, perfect black.
Yes. No. And then
in Punjab, there is a problem, and Dr. Joshi will endorse my view. You have fertilized in huge quantity. The ashes of fertilizers has deposited in the root zone of the field. That is why, and that has become an impervious layer.
Yes.
The whole soil taxonomy has changed.
That is why fertility has reduced.
pH values have changed.
Natural percolation has been reduced, and that is why artificial recharge system is introduced.
But then the underground water withdrawal is going on unabated. That is there.
No, sir, that is correct. That underground water withdrawal will go on because supposing if I want water, where will I go? The government can't give me, then what will I do?
And
I'll go for that only, no?
And I will give you a ritual example of one state. In Bihar, you might have heard about Chhat Puja.
Yes.
What is Chhat Puja?
You see, what happens after that?
Chhat Puja is the removal of silt bed after the rains, before near Diwali, so that next forthcoming rains can recharge into the groundwater. That is why complete Bihar is safe.
So that is the same Jatra I had spoken about. I had spoken about the Jatra in Maharashtra, why it happens. The same principle.
Yes, that is it. Yes.
So groundwater, rainwater harvesting, you might have gone through ancient buildings, numerous ancient buildings. Everywhere you will find a rainwater harvesting system.
Yes. You see, the ponds, village ponds have gone. They have been modernized.
Now ponds have become a sewage pond. That is the problem.
I think individual, especially in smaller cities, Mumbai has gone out of, I think, bounds with respect to the population. But in smaller cities, I think definitely individual units which are much smaller, rainwater harvesting is definitely possible.
Definitely possible.
Yeah, I mean, we look at the poles of Ahmedabad, even in those old houses, every house has a tanka, and they store water there. Of course, not maintained and all that things, but everybody way back thought of this.
Once I visited Mumbai and went to Siddhivinayak Mandir. So while taking this prasad, the concerned lady washed my hand through this bottle having few small holes by spraying like this. मैंने वहां से आके सीखा तो मैं अपनी गाड़ी भी उससे धुलवाता हूँ. And you will not believe my one SUV is being washed from 200 ml waters only.
Very good. Good.
And I prepare a caption. ये गाड़ी 100 लीटर पानी रोज बचाती है क्योंकि ये धोई नहीं पहुंची जाती है. So
Yeah,
Right.
likewise, so there are two aspects, conservation and preservation. We have to move in both the fashion. And one, I came to Kapil Sharma show as well. वहां पे मैंने उसको बोला था कि वो जो स्प्रे करते हैं, आप यू ऑल आर आर्किटेक्ट्स, जो स्प्रे जो वॉश बेसिस में लगते हैं, दैट शुड बी स्प्रे नॉट फ्लोइंग वाटर. तो उसकी नोजल्स आ रही हैं अभी, वो लगानी चाहिए. तो every single step can conserve the water.
Jain sahab, next
Rightly
concept is
said.
next
Rightly said
concept.
by
Sorry,
Deepak, sir.
the Mileka, just 1 minute.
Yes,
This
sir.
next concept is coming is use, throw, and throw away. That modular system. You see, repair and you reuse is not coming up. So we are wasting much more, polluting much more. That side.
Yeah.
Okay, sorry. Thank you.
No, no. Like rightly said by Deepak, sir, we should reduce, reuse, and recycle water and everything in our life.
People are principles should be used.
Yes, yes. So as we come to the end of today's webinar, so let us briefly discuss on the key takeaways. We began the session with Roshni ma'am, who highlighted the growing importance of sustainable water management and shared her practical experience of implementation of rainwater harvesting. Amar sir helped us in understanding the geological and scientific principles behind groundwater recharge aquifers and effective rainwater harvesting design. Ayush sir shared his practical insights on of modern rainwater harvesting technologies and solutions, and that those are being implemented across diverse projects. Finally, Deepak sir provided valuable perspectives on need for rainwater harvesting, CGWA guidelines, and real-world implementation, and the future of water conservation. So, on behalf of RUA Ecospaces LLP, I extend my heartfelt gratitude to all our distinguished speakers for generously sharing their knowledge and experience. A sincere thank you to all our participants for your enthusiastic participation and thoughtful questions. We hope today's webinar has provided practical knowledge and fresh perspectives that will inspire all of us to make rainwater harvesting an integral part of our sustainable development. So before you leave, we kindly request you to fill out the feedback form which is shared in the chat. Your feedback will help us improve and organize more meaningful knowledge series sessions in the future. Please stay connected with RUA Ecospaces LLP for upcoming webinars on sustainability, green buildings, energy efficiency, and other such environmental related topics. Thank you once again for joining us. Have a wonderful evening. Stay safe and let's work together towards a water secure and sustainable future. Thank you, everybody.
Thank you.
Thank you, one and all.